Greetings, the Astro 30 here, and this amplifier project is coming on nicely, but I'm going to need some form of mains line filter. Something to filter out the clicks, the pops and any other artifacts that might be present on the mains voltage line. Some sort of circuit. And that's exactly what this circuit is. It's an electromagnetic interference and a radio frequency interference filter, and it basically comprises of an inductor and a capacitor. Now this inductor actually shares the same bobbin that it's wound on, and this is basically an LC filter. This resistor here is to discharge the capacitor here, because this capacitor is attached across the active and the neutral wires, or the hot, the live, whatever you want to call it, and the cold. And this capacitor is responsible for filtering out any clicks and pops that you might get on the output of the amplifier from things turning on and off, such as fridge compressors. That's electromagnetic interference, and these inductors are here to filter out any high frequency radio signals that may be present on the line at any one time. And that is basically what I need. Say hello to my little friend. That's exactly what this is. It's a pre-built EMI RFI filter in a IEC standard computer style plug package, and I don't have to build a circuit or work out the inductance or the capacitance values, as you can just buy them ready-made like this with a nice insulated package. Now this is only about 10 bucks. You've got your live and your neutral coming out here and your earth down there. So basically all it is just a standard IEC socket which ends about here. Then there's a little small circuit board past that with the filter coil, the capacitor and the resistor, and then lugs soldered to the board out on the other side. And of course this earth is just extended through to here. So there we go. You may be asking yourself a valid question as to why I've got one. Well, I've noticed here on the mains circuit there is sometimes clicks and pops on, well, any amplifier that I've built that doesn't have EMI RFI suppression. And most good amplifiers, especially like Sony and all those other brands, do actually have line filters on their mains for that very reason. So that's the reason why I got that, because I want to eliminate as much as possible any clicks and pops that occur on the line when things like dryers, washing machines or fridge compressors turn on and off. And this section here, including that resistor, this round thing is a resistor, is exactly the same thing as I just shown in the schematic diagram on the whiteboard. There's the bridge rectifier over here and the large filter cap. This is part of a switching power supply, but that is the EFI RFI filter section right here. Because either the mains comes in here, I believe, because it's where the fuse is. I think that went to a switch from memory. So one of these leads goes to here and then comes back out through to the fuse, etc. But this is actually in line with the AC. So that is used as EMI RFI suppression. Well, at least I don't have to build one. And the value of that capacitor, it's an MKP capacitor rated at 275 volt AC. It's a 0.1 microfarad. So there you go. I'm not sure what the inductance of that coil is, but as you can see, the two separate coils share the same bobbin. A bit like a transformer in a way, but it's not a transformer because it doesn't allow induction between the two coils, because they are two separate coils. So there you go, that's what the EMI RFI filter looks like on any bog standard circuit board. So if you see this inductor with a bunch of capacitors around it and near the line input, that's what that is. So before I get too involved with building something else for this project, I want to know the burning question of how much current is each of those power amps drawing when it's running close to full power. Now, I did do a calculation in part 5, and I said that we had roughly a voltage peak of 60 volt peak to peak, and then we divided it by the load resistance. That gave us 7.5 amps. Well, that's fine for the output load, but that's not what the actual DC current draw is. Don't forget the output on the speaker is going to be AC. We know two values. We know what the wattage is, the calculated wattage, which is 112 watts. We also know what the output peak to peak voltage is. Now, if we use the inverse power law, that is, we take the power that we know, which is 112 watts, and we now divide that by the peak to peak voltage of 60. That will give us what the current would have been that we would have plugged in to actually calculate 112 using P equals V times I. So we're looking at 1.86, 1.9 amp roughly. So I expect to see on that multimeter there on the right of screen around about 1.9 amp at full output power. I noticed one other thing too with this DDS, that ever since I replaced that filter cap to a 2200 microfarad, the display initializes fine. So what I need to do is I need to set the amplitude to, I'll set it to 2 volt to start with. I don't know why it never changes the first time. I think the input sensitivity was about 3.5, 3.8, something like that. So I'll plug the amplifier in, and I've got one of the VCC lines disconnected from this module here going across the amp meter, and we'll read out what its current is. So currently we're about 20 mA. Still at 20 mA apparently, which can't be right. We've roughly got 52 volt coming out because I'm in times 10. So if I now wind the amplitude up until the signal clips, let's adjust that. Back it off till it stops clipping. Yeah, it's about 2.3. And we've got about 59 volt peak to peak there, so it's roughly correct. But I've still only got a current draw of 20 mA. That can't be right. Okay, so I've swapped the lead connections around for the multimeter because it was in reverse direction. Still got 20 mA. Still 20 mA. Okay, I'm confused. It should be more than that. Well, that could very well be because I disconnected the positive lead to the wrong module and I was measuring across the wrong module. So now that I'm measuring across the correct module, that 20 mA I was seeing was the quiescent current of the first module. So I'm going to plug the amp back in. Now we have something a little bit more reasonable. At full power output, we're getting 1.1 amps of current. So my calculation wasn't too far off, but the peak to peak voltage is now 58.4. Okay, so I now know that a 2 amp fuse in line with each VCC and each negative rail will be sufficient enough, because it's about 1.2 amps, so a 2 amp fuse will do. And I'll put 2 amps on both the positive and the negative, as I just said, because you'll never know that in the case of a short circuit which side of the amplifier output stage is working at any one time. Sometimes it can blow the positive fuse, sometimes it can blow the negative fuse. But if you don't have one on the negative, you've got a whole half cycle to come round to before it actually blows the positive fuse, so you could actually end up doing damage to the negative going transistor. So that's why you would always put 2, because it's bipolar. I have ordered some PCB mount and chassis mount type style, they're 2-in-1, fuse holders which I can then screw to the case here, probably just in front of the power supply. There's plenty of room here on this metal for that. Yeah, and they measure roughly 10mm by 20. So the fuse I'd be using is in about 6mm diameter by, I think it's 18mm long, so it's just slightly smaller than the actual outline of the casing that it goes into. And they also come with little plastic caps that you stick over it to, well, protect yourself from sticking your finger in it and getting a jolt. That's running on 250 volt mains AC though. Right, so now I know what the current draw is of the power amps at their full output before clipping. 2 amps, as I said, should suffice. So that's what I'm going to use. And today I received in the mail these sexy looking knobs, even though they're slightly different types. One's got a little dimple for the indicator, the other one's got a line. There's just one problem. The diameter of that hole, it's a grub screw fit, but the diameter of that hole does not fit this type of shaft. It won't fit in there, which is kind of a bit of a bugger. However, it does fit this fluted shaft style just fine. So that doesn't leave me a lot of options, because I'm going to have to probably use these fluted shaft ones, which I didn't want to do, which is specifically why I bought those flat shafts that you put a grub screw to. Once it's bolted to the sub panel, that's not going to leave a lot of meat sticking out the front there. I mean, well, it depends on how far I can actually bring the sub panel up to the front and how much is actually sticking out, because I got 3mm to clear the end of this shaft. So I'm not really sure what I'm going to do with that, but I mean, I could drill out that hole, but yeah, the likelihood of messing that up is really great. These are grub screw fit. They fit a small Allen key to do them up. This one's fairly heavy, but that's going to be my volume knob. This one's fairly light. That's going to be the bass, treble, mid-range, and the input selector knob. I've got 4 of them, 1 of them. I've got plenty of these variable resistors. I'm just trying to figure out how I'm going to solve this problem, because this headphone socket is also going to take up a bit of space with its nut behind the panel, and then there might be too much of it sticking through the front panel, so I haven't got much of a leeway there, and this is kind of annoying. Now the article did say that these are supposed to fit a 6mm shaft. These are a 6.5mm shaft. These would be a 6mm shaft. So what do you do about it? I don't know. So I'm just going to have a look at that. Yeah, it's 6.5mm, and this one, if I can just get the diameter, is about 5mm. Well, including the flute, I guess, the knurling, about 5.5, so closer to 6. A micrometer would be a better tool to use to measure that properly, but the diameter of that hole is borderline 5.5 from what I can eyeball, maybe 6. But the diameter of that shaft is closer to 6.5, and actually if you look this up in JCar, it says it's a 6.5 shaft, which is pretty standard for that, but it's not standard for that knob. And this is the JCar catalogue, and this is the single gang version of this potentiometer. The dual gang is the same shaft. Now, according to the technical drawing here, we can see that they're saying that the shaft diameter is 6.3mm. So it's a 1/4 inch shaft, but it's 6.3. These green things, PCB mount ones that are more common nowadays, it doesn't actually say what the diameter of the shaft is here, but it says its cutout hole is 6.7mm. So the actual shaft diameter will be closer to 6, which is why those type of shaft fit those knobs better than that type of shaft. And if you compare them side by side, they do actually look physically different in size. So that's a bit of a bummer. And I can't buy potentiometers in this size with that type of style of shaft on them anymore. Because they do actually make these Alps, I think they're called, type of potentiometers where the shaft actually sticks out a little bit further by at least another 5mm. So I might have to do some trolling of the internet and see if I can find some new pots. I'm not really happy, but I do want to use these because, well, I paid $5 plus shipping for this one knob alone, so I want to use it. So whatever I have to do is whatever I have to do. So I know this video is basically not really progressing any further with this build as I would have liked, but it's just giving you an overview of, well, where I'm going and the problems I'm now encountering as I go. Nothing is meant to be easy, as they say. But I'm glad that I've got the J-Car catalogue, because most of the stuff in the printed catalogue give you physical measurements and distances between pins and stuff of things that you buy, because it's a technical catalogue. So when you actually go to design, say, a circuit board around something, you know the exact physical measurements without having to look at a stupid PDF document. The website version for J-Car is a pain in the arse to navigate. You type in, say, potentiometer, and it'll bring up 1,175 different products, half of which aren't even related to a bloody potentiometer. So the website is a pain in the arse to use. The printed catalogue is, well, easy to use, but they also give you the measurements, whereas the online version doesn't give you half of these, technical diagrams. So that's a plus, and they actually gave it to me for free, so I'm quite happy about that. Maybe because I'm in there all the time, I don't know. I should start paying rent. Which brings me to the final topic. I've got some RCA sockets. I've got 5 red and 5 black for 4 inputs. Think about that for a second. Wait a minute, I've got 5 sets of RCA sockets for 4 inputs? No. See, what I'm going to do is, as I said, I was running out of room in the case to put that sub filter processor board thing in. What I thought I might do is, when the preamp is in, what I'll do is I'll actually mount a cable that goes to the back panel to 2 of those RCA sockets for a preamp out, left and right, which can then be plugged into a further power amp if I want. It comes after the volume control, but it can also go into the sub filter board and can be put into a separate case with a separate transformer, separate unit basically, to the amplifier, which can be turned off and on at will, so you can turn the sub on and off, because the sub is an active sub. It's always either on or in standby. There is no off switch. So I can either choose to have it on when I want it and turn it off when I don't, and still have 2-channel stereo. So that's the idea. I'm going to give it a preamplifier output jacks there to allow me that flexibility. And yeah, it saves a little bit of electronics on this particular project. But yeah, I've got to solve the potentiometer issue now. I really should have read and reread the description of these knobs before I bought them. But I just saw them and thought, oh yeah, that's perfect, a 44mm knob. Oh yeah, solid aluminium. Yeah, only accepts a 6mm shaft. Wow, what a fuck up. So I've got 4 of these potentiometers that I can't use. 3 are 50 kiloohm linear, and the other one is a 10 kiloohm log. And I can't use any of them. Oh well, so that means I'm just going to have to do a little bit more thinking and a little bit more modification. But this is what happens when you build a project. Things happen and mistakes happen, and you've got to go back and revisit things and rethink things as you're going along. Some things work, some things don't. Some things piss you off, some things don't. But yeah, that was my biggest piss off for today. But oh well. Okay, just before I go, that's been running for a good 40 minutes now. Nothing's getting overly hot. The relay is warm, but that's to be expected. And the dropper resistor near it is warm. The UPC, micro PC 1237 is nice and warm. But I wanted to end this video on a slightly high note. Oh! No. I did manage to find on eBay some replacement pots with the 6mm 18 tooth spline shafts, and these are roughly 15mm long by the looks of things, which is perfect. There's the other set down here. These are the 50k ohm linear. There's 4 of them, I only need 3, and there's one 10k. These 4 come from China, this one comes from Australia, so this is going to be another 3 weeks before I get them, and this one's only about a week. Now this will be perfect because the shaft is a lot longer than the ones I currently have, which are only around about 8mm long. So that is the replacement pots that I've got now. So I've got to wait for them to come in, but in the meantime, when I get the preamp and build it, I will use the 50k ohm pots that I've got on hand and then just change them later. And one more thing, the person that sold me the shitty second-hand 10,000 microfarad 50 volt used capacitors assured me that they only ever sell brand new parts. Yeah, right. And has promised me to send me 6 new ones. Okay, so I'll have 6 spare over in case I need to ever replace one. But yeah, I still don't trust him as far as I can throw him. But the amplifier is working happily in the background there. There's no smoke, nothing's getting overly hot. It's just working nicely. I'm just going to keep on soak testing it for the next hour or so and then put it away. Anyway, I'll see you in the next part. Thank you for watching this video. See ya. I'm the Astro 30, and as always, if you like this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyways, this is the Astro 30 saying, see ya, have a great day, and I'm not your Darlington.